You're listening to a podcast from 702 and Cape Talk.
702 and Cape Talk.
The Naked Scientist.
Call us right now if you've got a question for Chris. Remember, it gets very busy. You can ask him anything you want. I get most excited, although any question is allowed, when you ask particularly quirky, interesting questions about the world of science. We get a lot of medical questions. I do understand that because many of us have anxieties around our medical health. That's fine. Chris is very generous, but we love a vast array of topics and themes. So we'll prioritize those, but any question that you have on 011 883 0702 in Johannesburg and in Cape Town on 021 446 0567. If you don't want to call, you can also just tweet your question at 702, at Cape Talk or at Eusebius, or SMS as one. I'll check the SMS line periodically. We've got 25 minutes with Chris, so you can SMS a question for him by using the number 31702 or 31567. Hello, Chris. How are you?
Good morning. I'm very good. Thank you very much.
Chris, let's start with our science story of the week. And I'm quite excited about this one. I love it when one part of the magical world of science, like engineering, can have insights that we can bring to the molecular level.
Yes, and what this paper, which is in the journal Science this week, potentially offers us is a way to have a mobile phone that will go flat in more than 5 minutes. In other words, you can possibly not have to keep charging up your phone every 5 seconds. We may also use this technology in the future to usher in better electric vehicles so that we can ditch petrol and diesel as king of the road and all the pollution that goes therewith. I was intrigued by this because this paper, which is actually by researchers in Korea, it's Sung-hun Choi and his colleagues, they've actually taken science from about 2,500 years ago and brought it into the present era to solve our battery problem. Batteries are just not powerful enough. They're not capable of storing enough charge to do all of the things that we want to do with them. So what is the technology from 2,500 years ago? It was the invention of the pulley. About 2,300 BC, mankind first discovered that if you took ropes and you wrapped them around wheels and then you had mobile wheels within these lines of ropes, you could actually reduce the force you needed to do work. So you could move enormous things with much less effort. Well, the problem they've applied this to is that the present generation of batteries we have, the way that these lithium-ion batteries work is they have an electrode material inside the battery. At the moment we use graphite, or in some cases graphene, and lithium ions, particles of lithium, adsorb or soak into that carbon as the battery charges, and then when the battery discharges, the lithium comes out again. The problem is when the lithium ions go into the carbon, they make it swell. And if you make the carbon swell up and then you shrink and then swell and shrink with each cycle of charging and discharging, eventually it shatters the electrodes inside the battery, and this is what causes batteries to lose their lifetime, to lose their capacity and lose their performance. At the same time, carbon is quite resilient to this, which is why we use it, but it doesn't mean you can store very much charge. We'd like to use something that would enable you to store a lot more charge, because then the battery would be a lot more powerful. Problem is, silicon would be perfect for this job, but it swells up by, as the researchers themselves say in their paper, a huge amount. And this means that silicon just gets absolutely shot to pieces after very few cycles of charging and discharging the battery. What this group in Korea did was to say, well, can we engineer something into the battery material so that it spreads the load of this charging and discharging swelling more evenly, and in this way it will stop the thing shattering. So they've made these long strings of a polymer called polyethylene glycol. They've threaded onto it these rings of sugar molecules called cyclodextrins. So you've got to imagine a string with almost like beads on the string, these circles just floating along the string. This is amazing stuff. These are molecules they've done this with. They've embedded this inside the material of the battery. And now, when the battery charges and the silicon tries to swell as the lithium goes into it, then these circles help to distribute the load like a pulley system, which helps to spread the stress around the silicon so it doesn't fragment. Because as the battery discharges and things shrink, then the tension which is stored in these strings around the pulley system then winches the silicon particles back together, holding everything in place as it should be. And it means the silicon can hold a lot more charge without falling apart, and it doesn't seem to suffer if you keep charging and discharging it 150 times, they only got about a 10% loss of performance. So that's really encouraging. We could be on the verge of making much better batteries in future.
Fantastic. It will also prolong my social life, Chris. I wouldn't have to get anxiety about having to run home because the battery's dying.
Yeah, or be marooned in your battery car somewhere.
Yes, exactly.
Because that's the next big thing. We want the roads to be cleaner. We want the roads to be safer. We want people
100%.
to use electric cars because it's daft having petrol and diesel powered vehicles which are sitting in traffic jams. Much more efficient to have an electric car. But with an electric car that might go flat in the middle of nowhere and then you're marooned, who wants that?
Absolutely.
We need cars with better ranges. So as a result, better batteries are what's holding the whole thing back.
So now, Mo in Edenvale, what is your question for the Naked Scientist?
Morning, you CBS. Morning, Naked Scientist. Are you well?
We're very well, thank
Morning,
you.
I'm good, thank you.
Good. I've got a pot plant in my house, a normal pot plant that you keep to make your house look nice. It hasn't shed or grown a single leaf in over 5 months. So I want to ask, do plants go through a prolonged stage of hibernation or something similar to that? It's not growing, but it's not dying either.
Okay.
Yeah, well, it depends because some species, of course, never shed their leaves. These are evergreen. Other species are deciduous. They go through cycles. And the reason plants do this is that usually you see in the tropics where you don't have very much seasonal variation, you'll have plants that continuously produce leaves and either keep them all the time or produce new ones and shed new ones. Others follow the seasons. And the reason that at high latitudes they tend to follow the seasons is that the plant has made a judgment that there is a danger of having leaves because high winds could damage the plant, that there's not much sunlight around at high latitudes in the winter, so the cost of running your leaf and the cost of replacing your leaves when they're damaged by bad weather and frost and so on is not outpaced by any benefit of capturing that little bit of energy from the sun, so plants have evolved to have a dormant period. Now, I don't know what your house plant is, but it could be that some of these house plants, if they're not kept in ideal conditions, they are fooled into thinking that it's a winter or a non-growing season, and so they just reduce the metabolism of the plant. Under other circumstances, it might just be that it's a slow-growing plant and that in more optimal circumstances, better water, more light, it would grow more. But certainly, plants actually make a decision to shed their leaves. And the reason the leaves go through these colour changes is because the plant uses the leaf as a way to export waste products from the plant. So it recovers all the useful things from the leaf and takes them back into the plant before it drops the leaf. And it dumps the rubbish it doesn't want from the plant into the leaf and then throws away the leaf. So if your plant's just sitting there stably and happy and it's not losing leaves, that's a good sign, because the first thing that a plant is under stress, the first thing it does is it starts to lose leaves. So your plant is not too stressed, which is good. But if you want it to grow as well, you may need to feed it, you may need to give it some water, and you may need to give it more light and maybe more warmth, because plants are very sensitive to all of those factors in the environment.
Thank you so much. That's interesting. The reason I asked is because it used to grow a lot of leaves, and all of a sudden it just stopped without warning, and I haven't changed its position in the last year.
It may be that you need to repot it, right? Because plants are really sensitive to... People forget that the soil that the plant grows in, there's a whole community of microbes living in that soil. So it's not just the plant above the soil that you've got to worry about, because the plant is having an intimate relationship with fungi and bacteria in the soil. If the soil becomes unhealthy and you make your microbes in the soil unhealthy, the plant becomes unhealthy because they're all swapping molecules and helping each other out underground. So if your soil has got tired or fatigued and it's therefore compromised the microbes and the soil microbiome, the plant won't do well either. Your plant may well need repotting and feeding, which will feed your plant's microbiome, restore the integrity of that conversation going on underground, and the plant will recover and it will grow more.
All the best, Asenamo. Let's go to Erica in Pretoria. Welcome to the show, Erica. What question have you got?
Hi, thank you so much for having me. I would like to know if you can maybe assist me in explaining this 3AE phenomenon.
Yeah, the line's a bit horrible there. I think Erica's got an interesting question. We'll see whether we can come back to her. However, let's take John in the meantime in Benoni. Hello, John.
Hi, good morning. Thank you. Thank you for taking my call.
It is only a pleasure. Go ahead.
Thank you. Thank you. Chris, I'd like to ask, You know, a lot of people have a theory, which I should believe in, that certain people are affected by the phase of the moon. Now, I heard something this morning which is quite interesting. Somebody told me that they're convinced the same way the moon affects the tides, that it's perhaps because it affects the levels of water in one's body. Is that a possibility?
Hello, John. You're quite right that people are affected by the phase of the moon. There is evidence for this. There was a paper that was published in the journal Current Biology a few years ago where researchers, I think they're in Switzerland, had done a sleep study. And when you do a sleep study, you bring humans into a laboratory which is specially set up for people to sleep in it, but you remove all of the cues that would be in their home, like lighting, alarm clocks. You therefore impose your own time signature on the people in the sleep study so that you can control for those factors. But because they had all this data from a large number of people who'd done these sleep studies and they knew what dates they'd done them on, some bright spark, about 10 years after they did the original study, said, well, let's have a look at what the moon was doing when these people came into the sleep study. And they found that there was this very strong relationship between people declaring poor sleep in certain parts of the study and certain phases of the moon. And this was a really strong relationship, which wasn't just a statistical glitch. It looks real. And so there does appear to be some kind of entrainment in our human psyche by the moon cycle as well as the daytime cycle. We have a body clock running in our brain that knows what time of day it is. It would appear that we also have in some way some influence on our body from what the moon is doing. However, the influence of the moon is likely to be one in terms of the amount of light reaching the Earth or some other behaviour that changes with the moon cycle. It's very unlikely to make a biochemical difference in terms of body water. The moon does make water move around on Earth for various reasons, gravitational ones, but the difference it will make to your body water is absolutely minute in comparison, unless the biochemical effect of the moon changing your behaviour causes you to drink a bit more or pee a bit more, for example. But I don't think the moon's going to influence your total body water, but there is evidence that the moon does appear to have some kind of subtle effect on human behaviour.
20 minutes after 10, let's give Chris a bit of a break there for his voice. We'll take a commercial break here, and then more of your calls about the weird and wonderful and fascinating world of science. What questions do you have for him? Fastest fingers first. You've got about 10 more minutes to get in your question. You can call me on 011 8830702 and put the question to the Naked Scientist. Or if you're in Cape Town, you can do so on 021 446 0567. Or you can also tweet the questions. I'll have a look at Twitter. Here's a tweeted question. Chris doesn't need to answer. What's the difference between witchcraft and magic? Who's Seelan Gog?
702 and Cape Talk.
The Naked Scientist.
Chris, let's take one from SMS line. Karen says, why is it that if I weigh myself in the morning before I take a bath, I get a reading of a higher weight than 30 minutes later after I've taken a bath, and then I'm always 300 grams less?
Okay, there's a number of things here. One is that the scales are not calibrated terribly well. That's a possibility. And that these scales always wander a little bit. So these are not scientific instruments. So that's the first thing to consider. Two, if it's a really hot bath, you actually get quite hot in the bath and you may well sweat. And sweating would be 300 mils, would be 300 grams. That's 300 millilitres of fluid that you've lost. So some of it could have gone in sweat. Also, did you go for a wee? Because your bladder volume could be up to a litre. Most people pee about 300 or 400 millilitres when they go for a wee, and that would also account for some of the fluid loss. So it may well be that the person's behavioural pattern in the morning is to get up, weigh themselves, then you have a bath, sweat a bit, go to the loo, maybe number one and number two, and also breathing, just breathes out some water. All those things are going to cause you to lose a little bit of fluid, and that will contribute to a reasonable drift. On top of that, the scales are probably a bit inaccurate as well.
Okay. Let's take one from Twitter before we go back to the phone lines. Eben wants to know, and I've no idea what he's talking about, but I know that you will. Please ask Chris whether there's any merit at all to the Black Knight satellite theory.
I don't know what the Black Knight satellite theory is.
Oh, we've stumped Chris.
Someone can come
a rare moment.
Someone can come in and and they can elaborate, because I don't know anything about that. I'm sorry.
Okay, well, I'll give you some homework, but I've quickly Googled it while you were speaking there. I'm very quick. It says the Black Knight
You
satellite
must be. I didn't
conspiracy
hear that at all. I
theory.
didn't hear your fingers.
The Black Knight satellite conspiracy theory claims, Chris, that there is a spacecraft in near polar orbit of the Earth that is of extraterrestrial origin and that NASA is engaged in a cover-up. Oh, just sounds like good old conspiracy. Let's go to Midrand. I'm sure Chris will have a look at that. Mark, welcome to the show. What question have you got for us?
Two questions, really.
Just speak up a little bit there, Mark, so we can hear you clearly.
Regarding gas heaters, we use them in winter. Do you know anything, any side effects that we might get as a result of using them? And lastly, the microwave ovens. Any dangers to our health when we warm our food in the ovens?
Thank you for those questions,
Hello,
Mark. I'm
Mark.
so glad you've asked them, because I always have debates with my partner about gas heaters. I don't like them. I wonder if I'm being irrational, Chris.
It depends what sort of gas heater we're talking about. If they're working properly and they've been regularly maintained and they're safe to use, then there should be no problem with a gas heater. What that's doing is it's taking a fossil fuel, which is usually butane or propane gas, which are short chains of carbon atoms. It's reacting them with oxygen from the air, and the products of that reaction, if it burns cleanly and with a nice blue flame, will be carbon dioxide and it will be water. The danger with any kind of fossil fuel source when you burn it is if there is insufficient supply of oxygen, then you can get partial combustion. And what partial combustion means is that you don't complete the reaction making just carbon dioxide. If there's not enough oxygen to go round, you can't give each carbon atom 2 oxygen atoms to make carbon dioxide. And you can end up with a carbon atom having to only have 1 oxygen atom, and that's carbon monoxide. And this is very poisonous. And many of the deaths that occur because of poorly maintained boilers and heaters and things occur because of carbon monoxide poisoning, usually because the flue becomes obstructed and the gases can't escape, and the build-up of carbon then starts robbing the oxygen off of carbon dioxide, or it can't form that properly, so you get carbon monoxide. And it's dangerous because carbon monoxide locks onto the hemoglobin in your blood, and hemoglobin is the pigment that carries oxygen from your lungs to your brain and your muscles. And if the carbon monoxide gets onto the hemoglobin, it holds on very tightly and doesn't let go. So it stops oxygen going on. So your hemoglobin cannot supply oxygen to your tissues. And that's why these things are dangerous. But well maintained and used properly, so they're not going to start a fire or anything, they should be quite safe and quite effective. There was a second question, which
Microwave
was microwaves.
ovens,
The way that microwave ovens work is that they use a source of microwaves, which is about 2.5 gigahertz, so 2.45 gigahertz is the actual frequency. So what that means is the microwave oven is making microwaves, which are a form of electromagnetic energy, just like light is an electromagnetic wave, which whizzes backwards and forwards across the microwave 2.5 billion times a second. The wavelength that's chosen, or that frequency, is very good at making water molecules vibrate. They try to flip backwards and forwards 2.5 billion times a second. So when you put something in the microwave oven, the water molecules in the object that you put in, the food or the liquid, or even things like plates, anything with water that's embodied in the material, the water molecules will shake around inside the material, and the water molecule shaking around is rather like you rubbing your hands together. On a cold day, you might rub your hands together, and the friction of you rubbing your hands together generates heat. Well, the water molecules are trying to rub against each other 2.5 billion times a second in sync with the microwaves in the oven, and that's what imparts the heating effect to the food. As far as we know, this is a safe process as long as you heat your food properly and thoroughly. Most microwaves these days have either a rotating microwave source or a turntable to make sure you do get thorough heating of the food or drink item. Why I say this is that because it's a wave, that means it has a peak and a trough, and between the peak and the trough is an area where there's zero energy or very low energy. So you can get spot heating of food. And so some areas can get very, very hot, but other areas can be very, very cold. Similarly, you can end up with liquid. If you put liquids in the microwave, you can have an area of the liquid which is beyond boiling point and another area that's colder. And if you disturb that, it can suddenly expand and spray hot liquid on you. So you have to be very careful if you microwave liquids. But as far as we know, the energy in the microwave is not sufficient to damage or rearrange the molecules in food and drink in such a way that they should be harmful to health.
Stunning. Chris, have yourself a gorgeous weekend. We'll chat again next week, Friday.
I'm looking forward to it. Eusebius, thank you very much. Thank you, everyone. Great questions. See you soon. Bye-bye.
Cheers.